Welcome back to Daily Dose of Space. When we look at the universe today, we see light everywhere. Stars, galaxies, nebulae glowing across unimaginable distances. But for a very long time, none of this existed. There was a moment in cosmic history when the universe was completely dark. No stars, no planets, no light sources at all. And then, slowly, something changed. The first stars appeared, and with them, the universe stopped being simple forever. The darkest age of the universe. After the Big Bang, the universe expanded and cooled. Particles formed, atoms appeared, hydrogen and helium filled space almost uniformly. But despite all of this, the universe was still dark. There were no stars to ignite, no galaxies to shine, no heavy elements to build complexity. This period is known as the Cosmic Dark Ages, not because it was dangerous or violent, but because there was literally no visible light. Gravity was quietly at work, pulling slightly denser regions of gas together over millions of years. Tiny imperfections in the early universe slowly grew. Nothing dramatic happened quickly. Everything took time. And that makes what came next even more remarkable. Stars that were nothing like our sun. When the first stars finally formed, they were nothing like the stars we see today. They were massive, often hundreds of times heavier than the sun. They burned incredibly hot and incredibly fast. These stars were made almost entirely of hydrogen and helium because nothing else existed yet. There were no heavier elements to help regulate their growth or control their internal processes. As a result, they were unstable. Many of them lived only a few million years, which is almost nothing on cosmic timescales. But during those short lives, they fundamentally transformed the universe. They flooded space with the first starlight. They began ionizing surrounding gas. And deep inside their cores, they created something that had never existed before. New elements. The birth of everything else. Before the first stars, the universe had no carbon, no oxygen, no iron, no silicon. Everything we associate with planets, chemistry, and life simply did not exist. The first stars changed that. Through nuclear fusion, they forged heavier elements and released them back into space when they died, often in powerful supernova explosions. Those explosions were not just violent endings. They were acts of creation. The debris from the first stars became the raw material for the next generation of stars. Those stars were smaller, more stable, and longer-lived. Around them, planets could finally form. Every atom in your body that is heavier than hydrogen was created in a star that came after those first ones. In a very real sense, the first stars made the universe capable of remembering itself. Turning on the cosmic lights. As more first-generation stars ignited, their combined radiation began to change the universe on a massive scale. The neutral hydrogen that filled space started to become ionized. Light could now travel freely across vast distances. This period is called cosmic reionization, and it marks the moment the universe became transparent. Before this, light was trapped. Afterward, it could move. Galaxies began to form. Structures emerged. The universe became something we could, in principle, observe. Without the first stars, the universe would still be dark, opaque, and lifeless. Not dead, but unfinished. Why we can't see them directly. Here's the strange part. Despite their importance, we have never directly observed a true first-generation star. They existed so early and for such a short time that their light is incredibly difficult to detect today. By the time it reaches us, it is stretched into wavelengths that blend into the cosmic background. We know they existed not because we see them, but because the universe behaves as if they did. The chemical composition of ancient stars, the structure of early galaxies, the state of intergalactic gas, all of it points back to a population of stars that lit the first fires of the cosmos and then vanished. Ghosts of light that shaped everything and left no direct image behind. A universe that could have stayed dark. Perhaps the most unsettling realization is this: the universe did not have to produce stars at all. If early density fluctuations had been slightly weaker, gravity might never have pulled gas together strongly enough to ignite fusion. The universe could have expanded forever as a cold, dark fog. No stars, no galaxies, no chemistry. The first stars represent a tipping point. Once crossed, complexity became possible. Once missed, it never would have begun. In that sense, the universe we see today is the result of a very delicate beginning that succeeded just enough. Why this still matters today. Modern telescopes like the James Webb Space Telescope are now pushing deeper into the early universe than ever before. We are not looking for beauty. We are looking for origins. Every faint galaxy observed at extreme distances brings us closer to understanding how the first stars formed, how they lived, and how they changed everything that followed. Because without them, there would be no Milky Way, no Earth, no observers asking these questions. The universe's story does not begin with life. It begins with light. The first stars are long gone, but their legacy fills every corner of the cosmos. They turned darkness into structure, chaos into chemistry, and a simple universe into a complex one. Thanks for watching Daily Dose of Space.